Hello, good morning and welcome. This is our last chapter on the exercise we are treating on probability, exercise 11E. So, the first question here says, please, if you haven't subscribed to this channel, do well to quickly do that and click on all notifications so that you can get notifications once we drop these classes. All right, the first question says a pair of dice are thrown. What is the probability? What is the probability of getting at least 1/6? Now, the pair of die means two dice. These are the results from one die. These are, the results from another die. So this means that in it's possible to get one from the first die and one from the second die also. It's also possible to get one from the first die and two from the second die. So we go on and on like that and form all the possible outcomes that we can get from tossing those two dice. The question now says, find the probability of getting at least 1/6. At least 1/6 means 1/6 or 2/6. I hope I indicated it correctly here. At least 1/6 means 1/6 or 2/6s. Or should we say 2/6? So here, all of these results contain at least 1/6. There are 36 possible results, 36 different possible outcomes that we can get from the two dice. And these are the ones that include or that, bring up at least 1/6. So altogether, there are 11 if you count. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So number of required outcomes using your formula, number of required outcomes over number of possible outcomes is what? 11 over 36. So this will give you the answer to question A. Take note of that. Next question, B says, find the probability of getting a total score of 7. Of all these outcomes, how many will give us a total score of 7? 7 should be maybe aligned on a margin. Let's check. This is 1 plus 6 will give us 7 here. Okay, this is 1 plus 6 will give us 7. Let me use that. 2 plus 5 will give me 7. 3 plus 4 will give me 7. 4 plus 3, 5 plus 2, 6 plus 1. So all the results that give me 7 are on this axis. These are all results that give me 7. Let me try and be neat. Just mark it down. So how many are they? 1, 2, 3, 4, 5, 6. So my number of required outcomes will be 6. And my total number of possible outcomes is 36. So 6 over 36 gives you 1 over 6. Probability of getting a total score of 7 is 1 over 6. Let's go to question 2. It says, a game is played with a fair pentagonal, blah, blah, blah. So if in two spins, what is the probability of getting 2 5s? These are the possible results. 1, 2, 3, 4, 5. And it is said that it is fair. So the chances of anyone showing up is the same. The score on the side which comes to rest on the table, okay, is shown in the figure above. So this score here now is 3. The question now says, in 2 spins of the pentagonal spinner, what is the probability of getting 2 5s? In 2 spins of the pentagonal spinner, what's the probability of getting 2 5s? So probability of getting 2 5s will be probability of getting 5 in the first spin and 5 in the second spin. This means probability of getting 5 in the first spin and getting 5 in the second spin. So we work that together because these are independent events. What you get in one spin does not depend or affect, does not depend on or is affected by what you get in the second spin. Independent events. They are independent events. The first spin is independent of the second spin. So we use this multiplication. Probability of getting a 5 in the first spin is 1 over 5 because there's just one 5 and there are 5 possible outcomes. 1, 2, 3, 4, 5. So probability of getting 2 5s in 2 spins will be what? 1 over 5 times 1 over 5. That gives you 1 over 25. Okay. Probability of getting at least 1 5. Okay, question B says find the probability of getting at least 1 5. At least 1 5 means probability of getting either 1 5 or what? 2 5s. Now, there are many ways of getting 1 5. You can get a 5 in the first spin and another number in the second spin, or get another number in the first spin and 5 in the second spin. I hope you are getting that. There are two ways of getting 5. It's either you get a 5 in the first spin, and let's say you get a success in the first spin, you get a 5. Let's use P for success. You can get a 5 in the first spin, which is success, then in the second spin, get another number. Or fail in the first spin, that means you don't get a 5 in the first spin, then in the second spin, get a 5. So these are two ways of getting 1 5. So we are still looking for number of ways of getting 1 5. So probability of getting 1 5 is NR over NS. What does that give you? NR over NS is what? 1 over 5. So let me clean this away from, so that, okay, let me just put it here. PQ or QP, because it's actually relating to getting 1 5. So let's say probability of getting a 5 is success P. That would be 1 over 5. Probability of not getting a 5, let's say that is failure Q. That's 4 over 5. So that means probability of getting 1 5 will now be probability of getting 5 in the first spin, 5 in the first spin, that's success, then another number in the second spin, that's failure, or another number in the first spin, then 5 in the second spin, that's failure and success. So you can get 1 5 by succeeding first time, failing second time, or failing first time, succeeding second time. That's what this circles mean. You can succeed first time, fail second time. That means you get 5 first time, you don't get 5 second time. Or you fail first time, that means you don't get a 5 the first time, and succeed second time, you get a 5 second time. So your probability will be calculated like this. Probability of getting a 5 is 1 over 5. Not getting a 5 is what? 4 over 5. Or not getting a 5 first time and getting a 5 second time. Don't forget that multiplication means and in probability. So the probability of getting 1 5 will be 4 over 25 plus 4 over 25. That gives you 8 over 25. Please take note of that part of the question. Now, probability of getting 2 5s is getting 2 successes. Success first time, success second time. That means you pick first time, or you spin first time, you get a 5. You spin second time too, you get a 5. The probability of each one is 1 over 5. So getting a 5 first time is 1 over 5. And probability of getting a 5 the second time is also 1 over 5. That gives you 1 over 25. So put together now, probability of getting at least 1 5, which is the same thing as 1 5 or 2 5s, will now be the sum of probability of getting 1 5 and probability of getting 2 5s. So you add, you get 9 over 25. Question C says you should find the probability of getting a total score of 5. Probability of getting a total score of 5. So this one will require a table. Let's say in our first spin, these are the possible outcomes. We could get any of 1, 2, 3, 4, 5. Also in our second spin, let me clean this line. Also in our second spin, we could get any of 1, 2, 3, 4, 5 as well. So to get a total score of 5, that means okay, let's now make a table of the sums of our result. If I get 1 in the first spin, 1 in the second spin, my total will be 2. If I get 1 in the first spin, 2 in the second spin, my total will be what? 3. If I get what? if I get 1 in the first spin, 3 in the second spin, my total score will be 4. If I get a 1 and 4, total score is 5. 1 and 5, total score is 6. 1 and 5. So I've actually not written those results, but I wrote their sums straight away. So this one means that I get a 5 in the first spin, 5 in the second spin. Total score is 10. This one will mean I'm writing, the results from this axis first before the results from this axis. So this will mean 5, 4. This will mean 5, 3. Total score of 8, and so on and so forth. So of all these possible outcomes, which are how many altogether? I think they should be 5 times 5, 25 altogether. The possible outcomes or sums I can get in 2 spins are 25 different results. So of these 25 results, how many of them are 5? So you just count. These are the results that are 5. So probability of getting a total score of 5 is 4 over 25. Can you see that? Number of required outcomes will be 4. Number of possible outcomes, possible sums, is 25. So probability of getting a total score greater than 5. Okay. This one is now asking us what's the probability of getting a total score greater than 5. After marking out total score of 4, of what? After marking out the total scores, which are 5, all other remaining scores on the underside of that blue ribbon are greater than 5. So all these scores are greater than 5. All these scores are what? Greater than 5. So we just count them. How many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that means probability of getting a total score greater than 5 is 15 over 25. You use the same formula, NR over NS, number of required outcomes over number of possible outcomes. You simplify it into the lowest fraction, and you get 3 over 5. That's question 4. Sorry, that was question 3. Now question 4 says, when 2 dice are thrown, what's the probability of the total score being a prime number? When 2 dice are thrown. Okay. I think there's another question left in number 2. Okay, that was number 2, not 3. So let's go to number 3 now. Number 3 says, when 2 dice are thrown, what is the probability of the total score being a prime number? Okay, that's pretty simple. I think I skipped that. I didn't do it. Okay, we're going to do it together now. Okay, let's use this table. What's the probability of the total score being a prime number? Let me just squeeze it here. I will now take it to another part of the page. When 2 dice are thrown, what's the probability of the total score being a prime number? Let's use a table that shows us the total score when 2 dice are thrown. I don't think we have it. Do we? Let me check. I think I found the table like 2 or 3 times in the exercise. If we don't, then we have to draw another one. Okay, this is one here. Let's just use this. There's a table in question 16 for sum of results when 2 dice are thrown. The probability of getting a total score, which is a prime number, we just count the prime numbers, that's all. Let's just count how many of these results are prime numbers. 2, 3, prime, 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 this. All these numbers I'm circling are prime numbers. Prime. That's all. In each row, I've circled all the prime numbers. We are not answering question 16. I'm just using this table. 5, 7. Okay, so if you count, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 prime numbers there. Okay, so you now do NR over NS to get your answer. Let's actually do question 3 here. Let's answer question 3 here afresh. When 2 dice are thrown, the possible outcomes are, when 2 dice are thrown, 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Let's just make this as neat as possible. So the possible sums are 2, 3, 4, 5, 6, 7. Here, 3, 4, 5, 6, 7, 8. Here, 4, 5, 6, 7, 8, 9. Here, 5, 6, 7. This one will be 4 and 1. So 5, 4 from this die, 1 from this die. So on and on like that. I'm sure you understand that now. 5, 6, 7, 8, 9, 10. This is 6, 7, 8, 9, 10, 11. Let me write that very well. And this is 7, 8, 9, 10, 11, 12. So how many of these results are prime? Prime, 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 prime. All these numbers are prime, 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 and prime. So if you count, how many are they? Let's count. That's 1, 2, 3, 4 in the first row, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the probability of getting a total score, which is a prime number, probability of getting a total score, which is a prime number, a prime total is what? A total score, which is a prime number. The probability of getting that is number of required outcomes over number of possible outcomes. That's 15 over 36, and that's what? 5 over 12. So you take, that's for number 3. Let's now go back up to number 4. I'm sorry, I have to find my way back to the exercise. Okay, I'm back there. Number 4 now. Okay? In question 4, it says, in a large crowd, there are 3 times as many men as women. Okay? In a large crowd, there are 3 times as many men as women. So that means if the number of men is X, number of women will be 3X. 3 people are chosen at random. Assuming that there are so many people that choosing 3 has a negligible effect on the proportion of men to women. Find the probability that they are all men. Find the probability that there are 2 women and 1 man. Okay, so let the number of 3 times as many men as what? Women. So let the number of women be, let the number of men be X. Let the number of women, if the number of men is X, the number of women is 3X. That statement means number of women is more than number of men. 3 times as many men as women. So if the number of men is X, the number of women is what? 3X. So the total number of people in the large crowd, the total number of people in the large crowd is X plus 3X. That gives you what? 4X. Take note of that. Now, probability of choosing a man is simple. Number of required outcomes over number of possible outcomes. That gives you X over what? X plus 3X. That's X over 4X, which is 1 over 4. Also, probability of choosing a woman is NR over NS. 3X over 4X. or x plus 3x, which gives you 4x. That's 3 over 4. Okay. Now, if 3 people are chosen at random, what's the probability that they are all men? Probability that they are all men means the probability that the first is a man, second is a man, third is a man. So 1 over 4 times 1 over 4 times 1 over 4 gives you 1 over 64. Probability that if 3 people are chosen, find the probability that there are 2 women and 1 man. There are many different ways this can happen. It could be woman first, woman second, then the third person chosen is a man. That's 2 women and 1 man. Also, the first person could be a woman. You could choose a man as the second person, and the third time you could choose a woman. So that's woman, man, woman. You could choose them in that order. Or you could be lucky to get a man first time, woman, woman, second and third times. So we now do this. And since the number of people is not reducing as you choose each, your probability will be in this order. So all means addition in probability. So we put plus signs in the middle of all this. We could keep brackets on them if we like. Let me do that for you. You can keep this bracket on each. So probability of choosing a woman 3 over 4, a woman 3 over 4, then third time probability of choosing a man is 1 over 4. You did the same thing for the remaining brackets. In this bracket, probability of choosing a woman is 3 over 4. Probability of choosing a man, 1 over 4. Then probability of choosing a woman again is 3 over 4. You did the same thing to the third bracket. Probability of choosing a man first time is 1 over 4. If you choose another person second time, probability that the person is a woman is 3 over 4. And if you choose another person, the probability that that person too is a woman is 3 over 4. So you put your numbers together. Oh, sorry. This should be plus sign, not multiplication sign. So you put your values together like that. Get 27 over 64. It said in a classroom, 4 out of 5 students have calculators. Some must have lost theirs. The probability, if 2 students are chosen at random, let me read from the question. In a class, 4 out of 5 students have calculators. If 2 students are picked at random, what is the probability that both have a calculator? Only one has a calculator. Okay? The probability that both have a calculator is the probability that the first one has and the second one has. First one has a calculator and second one has a calculator. So we use multiplication here between the two probabilities. Exactly. Now it says, let C be the probability that a student has a calculator. If C is the probability that a student has a calculator, that means probability that both of them have a calculator will be C times C. Exactly. The probability that a student has a calculator is 4 over 5 because 4 out of 5 have a calculator. The probability that a student does not have a calculator will now be 1 minus C, which is 1 minus 4 over 5, which is 1 over 5. Exactly. You can include that in your mind or somewhere. So probability that both of them have is 4 over 5. The first one has a calculator and the second one has a calculator too. Exactly. So that's 16 over 25. The probability that only one of them has a calculator, that one is pretty different, but although it's simple. I've written this down there too. We don't need this here anymore. Okay. Probability that only one of them has a calculator is the same as probability that the first one has. Okay, I've done the calculation of probability of a student not having a calculator here, so you can see that. Now, if only one of them has a calculator, when you choose 2 students, the probability that only one of them has a calculator is the probability that the first one has and the second one does not have, or the first one doesn't have and the second one has. You understand? Choosing only one which has a calculator can occur in two ways. Either you are lucky first time, the first person you choose has. Second time, the student you choose does not have. Or first time, the student you choose has a calculator. Second time, first time, the student you choose doesn't have a calculator, but the second time, the student you choose has a calculator. So that's 4/5. That's what 4/5 times 1/5. Or first time the student doesn't have, the first student you choose doesn't have, and the second student you choose has. I'm writing those words so you know how to use them. You add, you get your answer. Okay. I've actually done everything, but I don't want this video to get too long, so I'll pause here, then we'll continue in the next video. But let me just scroll. I'll give you an exercise at the end of